this video we're going to discuss CRA models for both terminating decimals and repeating decimals. Okay, so we're going to start, and I'm actually just going to show the concrete and the abstract models here. The representational models will just be drawings that would align with the base 10 blocks if you wanted to use the representational models. So we'll kind of jump in with the terminating decimals first. So a terminating decimal just means that it will reach some endpoint to where we don't have to keep writing digits. Okay, so it's if we get to the case where we have zeros, so if we would just be writing all of these kind of trailing zeros, and we don't need to write all of those because it's just saying there's a quantity of zero in all of these, so that that decimal will end or terminate at some point. Okay. So what we're going to show is this terminating decimal of 25 hundredths, so why that stops there. Okay, so start with the fraction 1/4. This square is going to be our value of 1, so this is 1 whole. And since our denominator is 4, that means we want to divide this into 4 equally sized parts, so 4 parts that will make up that whole. And we just want to look at the size of one of those groups after we've created fourths. Okay. So since we just have the 1 part, we need to regroup this into tenths. So we have 10 tenths here. Okay, so now that we have 10 parts, we can put two tenths into each of those groups, right? So these are each of our 4 groups. Okay, so we have 2 tenths that are left over. Okay, so we can't distribute those amongst the 4 groups and keep them equal as is. So these would need to be regrouped as well. So actually I already have those regrouped into all of our hundredths. And then again, we could go one at a time, but we need to divide these into 4 equal groups, but we're just going to go in the chunks of 5 just in the sake of time. Okay, so all of our hundredths have been distributed. So again, the size of one of those fourths, right? These are each a fourth of that whole, because we made 4 equal parts from that whole. We know the size of 1, so here we have, right, 2 of our longer strips, so those are each tenths. That's why that 2 goes in the tenths place. And the smaller cubes are all hundredths. We have 5 of those. That's why the 5 goes in the hundredths place. And the reason that the decimal ends there, why it terminates, is because we don't have any part of our original whole that still needs to be distributed amongst those 4 groups equally. So since our process of division has ended or has been terminated, then that's when that decimal will terminate as well. Okay, so that's our first example. Again, that's the concrete model, and then the abstract model there. And then for the repeating decimal, we're going to start with a different whole for this one just to show one more step in this. But a repeating decimal is just where that process of division, you would have to repeat that over and over and over again. Okay, so this is our abstract model for a repeating decimal. So how we would read this is 0.3 repeating, or 3/10 repeating. Okay, so we can write it like this with just 1 3. That would be just as correct if we were to write it this and have the line over just that last 3, or have the line over all. We just need to make, like for this fraction, there is some, or for this repeating decimal, there is some flexibility since it's just the same digit repeated over and over. For some repeating decimals, the digits will be different, but they'll be repeating in the same pattern over and over. So just whatever that pattern is, that's what that repeating line will be over. Okay. So for this one, again, a little bit of flexibility since it's just all 3s. So for this one, we're going to start with that large cube as our whole. So this will be equal to 1. Okay, so we want to divide this again. We're going to divide that whole into 3 equal parts since that's our denominator, and then we're just going to look at the size of one of those parts. Okay, so this needs to be regrouped. So I've already regrouped this here into tenths. So we have 10 tenths instead of 1 whole. So then we're going to create 3 equally sized groups. I'll just kind of stagger these a little so we can see the quantity of each. Okay, so each group, each of the three equal groups has 3/10. But then we have, sorry, I already have it ungrouped, but if I hadn't ungrouped it already, we'd have 1/10 left over, so that would need to be regrouped into 10/100ths. Okay, so we have 10/100ths, so you can see we're going to put 3 of these into each group. Okay, and then we have 1/100th that's left over. Okay, so far we started with the 10/10ths. We put 3 in each group, we had 1/10 left over. Then we had the 10/100ths, we put 3/100ths in each group, and then we had 1/100th left over. So again, we're going to regroup this into thousandths, which I've already done. And we're going to place 3 into each group. And then again, we'll have 1 left over. So we always have this 1 that's left over. Okay. So if we wanted to continue this, which we can't with this concrete model because I can't cut this apart, but what we would need to do is we need to cut this tiny cube into 10 equally sized parts, so 10 little slices. 3 slices would go here, 3 would go here, 3 would go here, but then there'd be 1 tiny slice that's still left over. And that tiny slice would need to be cut into 10 strips. And then 3 of those tiny strips would go here, 3 go here, 3 would go here, but we'd have 1 tiny strip left over. So it doesn't matter how many times we would repeat this process of division, there will always be 1 tiny part left over, infinitely smaller as we continued with that process. Okay, so that process of division would keep on repeating, right? It would keep going over and over and over. Okay. So again, if we wanted to write this, we wanted to kind of keep track. When we put 3 of these larger squares in each group, right, those are 3/10ths. When we put 3 of these strips into each group, those are 3/100ths. When we put 3 of the tiny cubes into each group, that'd be the thousandths. And again, if we would slice this tiny cube, that's your 10,000ths. And if we cut the tiny slice into tiny strips, right, we would just continue on and on and on. So we don't need to keep continuing this because it's just going to repeat over and over. We're just always going to get 3. Okay, so we could have all those and just put the line somewhere over there, or we can just have it like this. Okay, but so you can kind of use the concrete models to show this idea of repeating, right? Because there'll always be, doesn't matter how small we get, there'll be some tiny piece that's still left that we need to put into the 3 groups. Whereas with that terminating decimal, that process of division was terminated because there was nothing remaining. Okay, so again, base 10 blocks are a good concrete model to use here, and then if we want to use the representational ones as well, it'll just be drawings that align with the base 10 materials. And then abstract model is pretty much just your standard decimal notation. And then for repeating, it's going to be that line over whatever digit or digits are the ones that repeat over and over.